So today we discuss the syllabus of ATO for diploma and degree category. Uh, we start the subject engineering chemistry, and the syllabus is physical chemistry, which include atomic structure, chemical bonding, solution, and electrochemistry, inorganic chemistry, which include metallurgy, alloy, and organic chemistry, which include hydrocarbon, and industrial chemistry, which include water treatment, lubricants, fuel, polymer, chemicals in agriculture. So our first chapter is physical chemistry, which include atomic structure, which will be discussed in the next chapter. So the chapter one is atomic structure. So the introduction is, so before starting we discuss the which books you have to refer for the chemistry. The book recommended is the textbook of Intermediate Chemistry Part 1, Part 2 by Nanda Das Sharma, which is publisher is Kalyani Publisher. And second book you have to follow BK Sharma. And third book ER Sharma and P Mitra, which is also Kalyani Publisher. Next book is the Engineering Chemistry for Diploma by Dr. R.K. Mahapatra. Next, Jain and Jain publication, which is Dhanpad Rai and Sons publication. So without any delay, let's start our chapter. Chapter 1 is atomic structure. So according to Dalton's atomic theory, every matter is composed of very small particles that calls atoms. So in Greek terms, atoms meaning A, and the atoms is divided A plus tom. So A means cannot and tom means caught. So that means which cannot be caught. That means which cannot be further subdivided. But in modern researchers reveal that atom is divisible and has a rather complex structure containing a large number of subatomic particles, such as electron, proton, neutron, meson, leptons, antiprotons, neutrons, antineutrons, positrons, quarks, etc. So the atoms are divided such as electron, proton, neutrons. This means electron, proton, neutrons, which are very important. And the fundamental particles are we have to discuss. Next, the atomic particles, that means electron, protons, neutrons, are the fundamental particles of all the matter. So electron, protons, neutrons are we have to discuss their properties. So first of the name is electron. So electron is a fundamental subatomic particle which have negligible mass of 9.11 into 10 to the minus 31 kg and carrying a charge. It is a negative charge, so the charge is value is 1.602 into 10 to the minus 19 coulomb. So we have to remember this mass of electron and the charge of electron. So the mass of electron is 9.11 into 10 to the minus 31 kg and charge is minus 1.602 into 10 to the minus 19 coulomb, and charge unit is coulombs. So you have to remember, it is very important for the exam point of view. Next fundamental particle is proton. So proton is a positive charge which contain 1.602 into 10 to the minus 19 coulomb, which is opposite, and the sign is positive. So 1.602 into 10 to the minus 19 coulomb, and the mass is 1.672 into 10 to the minus 27 kg. So the mass is 1.672 into 10 to the minus 27 kg, which is the mass of proton. Next, third fundamental particle is neutron. Neutron is no charge, that means neutral, and it has mass approximately near to mass of proton, which is 1.675 into 10 to the minus 27 kg. And among the three fundamental particles, electron has least mass, which is negligible mass, which is 9.11 into 10 to the minus 31 kg, which is least among the three proton neutrons. So this is the table you have to remember. Electron, which is mass given 9.11 into 31 kg, and charge is 1.602 10 to the minus 19 coulomb, and the relative charge is -1. So the next fundamental particle proton, which is mass 1.672 into 10 to the minus 27 kg, and charge is, which is the opposite, that means positive of electron, 1.602 into 10 to the minus 19 coulomb, and relative charge is +1. And neutron has zero charge, and the mass is 1.675 into 10 to the minus 27 kg, and relative charge is 0. Next, what are the models we have to remember? The first model is Rutherford models. That means Rutherford's gold foil experiment or Rutherford alpha scattering experiment. This is done for the discovery of nucleus. So in 1911, E. Rutherford gave the first information about the almost correct picture of an atom. So he bombarded a number of alpha particle. Alpha particle means helium plus 2 ions. That means helium, 2 electrons donated by helium. This is the alpha particle emitted from a radioactivity material like uranium on a very thin gold foil. So the alpha particle is bombarded on the thin gold foil, and a circular zinc sulfide screen is provided at the back side of this gold foil, in order to register the impression made by the alpha particle. And see the figure. This is the figure. This is the gold particle, gold foil, and backside is circular zinc sulfide, which is provided for the impression provided by this alpha particle, which is bombarded on this zinc, on the gold foil. So these are the alpha particle which is bombarded on the gold foil. So what are the observation we have to found and the conclusion? So from the alpha scattering experiment, Rutherford observed that most of the alpha particle went undeflected. That means they passed through the gold foil without any deviation. That means most of the alpha particle go through the this gold foil. That means almost all the particles which are go through this means there are some vacant space. So it is clearly indicated that most of part of the atom are empty. Next observation is a few alpha particles were found to be deflected strongly from their normal path. This indicates that the presence of heavy positive charge. That means this alpha particles are positive charge. That means some of the particles are deflected. That means positive will be repulsion. That means some parts that must be positive charge which is deflected. So he observed that a heavy positive charge body is called nucleus. So indicate that heavy positive part present inside the atom. So this he named that this positive charge carrying boundary is called nucleus. And a very few, that means 0.01% alpha particles are found to be retracted to their original part. That means deflected through almost 180 degree. Only one which is deflected return back to the original position. That means it indicates that the size of nucleus is very small. That means it presents the positive charge. Also, it is reflected by positive charge. That means there uh, there must be a positive charge which is bounded by small area, uh, because this ray deflected 180 degree to, that means the return to the original black position. So indicate that the size of nucleus is very small, and the size of atomic nucleus is order of 10 to the minus 13 centimeter. So the next is Rutherford's atomic model. It's called Rutherford's alpha scattering experiment or Rutherford Wolfram model. Next, that means Rutherford's atomic model. Based on the conclusion drawn from the alpha scattering experiment, Rutherford proposed the atomic model. Follow. That means based on this condition, he proposed the atomic model, which is as follow. Number one is an atom consists of two parts. They are nucleus and extranuclear part. Atom is consisted of nucleus and extranuclear part. Every atom consists of very small and heavy positive charge body called as nucleus. Next is the whole mass of an atom is concentrated on the nucleus, because outside the nucleus is the empty space, because most of the alpha particle went undeflected. That means they passed through the gold foil without any deviation. That means the most particles are empty, So the weight is normally depend on that heavy particle which is present on the nucleus. So next third point is electrons revolve around the nucleus with tremendous speed like parent planet revolve around the sun. Therefore, the electrons are also called as the planetary electrons. Next question, point is 4. Electrostatic force of attraction acting inward between nucleus and electron is balanced by centrifugal force acting outward arranged into the motion of the electron. That is why electrons do not fall in the nucleus. So the centrifugal force which is acting outward and balanced by the electrostatic force of attraction which is inward, so that the electron is do not fall into the nucleus and it is moved in their boundary. Next, what is the drawback of or failure of the Rutherford's atomic model? One is stability of atom. The theory fails to explain the stability of atom. According to the law of electrodynamics by Clerk Maxwell, whenever a charged particle revolves around a charged particle, the revolving charged particle emits lose energy continuously. So when a charged particle is revolved around another charged particle, then there must be a loss of energy. So as per the energy of the revolving electron decreases, it should be attracted toward the nucleus, as electron is negative charge and the nucleus is positive charge. When electron is revolving around their nucleus, and the energy losses by the electron. When energy loss is occur, then electron should be attracted by the positive nucleus. So it attracted toward the nucleus and should follow the spiral path and ultimately fall into nucleus. However, this is never happened. So it is unable to follow the stability of atom. This is the one drawback. Next is the model is silent about the definite energy and velocity possessed by the revolving electron. And this model is not to tell about the velocity and the definite energy of the revolving electron. Next, the theory is fails to explain the atomic spectra. Next, it fails to explain the cause of chemical combination. Next, our model is this is end of the Rutherford model. Next is coming to Bohr's atomic model theory. An almost correct picture of atomic model was provided by Dutch physicist Niels Bohr in 1913, and the Rutherford model is given by 1911. And after 2 years, Bohr's Dutch physicist Niels Bohr proposed a atomic model, and this atomic model is based on the Planck's quantum theory or quantization of energy. Next, the postulate of Bohr's atomic model. Every atom consists of a positive charged body at the center called nucleus, and electrons revolve around the nucleus in a certain permitted definite circular path called cells, and orbits called the cells or orbit or stationary state. Next, the stationary state or cells are designated by K, L, M, N, O, etc. for first and second and then third, fourth cells respectively. Next, each cell is associated with certain definite quantity of energy. Hence, the cells are called as energy level. As we state that the Rutherford model cannot possess the definite energy and velocity possessed by the revolving electron, and in this model, we have to the Bohr's associated a certain definite energy level of these cells. So this is cells called energy level. Next, the energy content of various cells are compared by formula. This is the formula: En is equal to minus 2 pi square m e to the power 4 z square by n square h square, where m is mass of electron and e is charge of electron and z is atomic number, n is number of cells or principal quantum number 1, 2, 3, and h is Planck's constant, which value is 6.625 and 10 to minus 27 or second. And after simplifying the value of, we get En is equal to minus 1312 divided by n square for hydrogen atom. Next, the energy content increases on moving from lower to higher cell and becomes zero for the cell which is present at infinite distance from nucleus. So this is the energy level which moving from 0 to outward, the energy content is 0 when infinite distance from the nucleus. This is the ground state. That means this is the nearest to nucleus, and this is the far away from the nucleus. The energy level are not equally spaced as you see. The energy level from the ground state N1 is high compared to second one. Next third one is decreases simultaneously. Though the large number of concentric circles are possible around the nucleus, those circles paths are allowed for electron to revolve, for which angular momentum value, which is MVR, is a whole number, which is a multiple of h by 2 pi. So the angular momentum MVR is equal to NH divided by 2 pi, where n is equal to 1 to 3. That means the number of cells. M is equal to mass of electron, V is tangential velocity of the revolving electron, R radius of orbit, and H is Planck's constant. When electrons in an atom are in the normal energy state, that means ground state, they keep on revolving in their respective orbit without losing energy. Next, when external energy is supplied to an atom, electron jumps from lower ground state to higher state. When a electron is supplied by energy, then electron from this lower state to jump to this higher state in excited state. Next, electron in excited state are unstable and jump back to the lower state by releasing energy. When excited state, it jump to the innermost cell by releasing some energy. This energy emitted is E2 minus U1, and this energy absorbed is E2 minus U1. So the energy thus releases appear in the form of light, which is in the origin of spectral lines, which is shown in the figure 1.4. Next, what are the failure or drawback of the Bohr's atomic model? According to Bohr's atomic model, the path followed by electron is two-dimensional circular. But the modern research, Heisenberg uncertainty principle, revealed that electron revolve in the three-dimensional path called orbitals. So these paths are two-dimensional, and but the modern researchers like Heisenberg's instrument they reveal that electron revolves in the three-dimensional path. And next failure is it fails to explain the spectra or of multi-electron species. Next, it fails to explain the relative intensity of spectral lines. Next, it fails to explain the splitting of spectral lines when exposed to electric field spark effect and magnetic field. This is called Zeeman effect. Next, it fails to explain the cause of chemical combination. These are the 5 failures of Bohr's atomic model. Next is Bohr's scheme. Bohr's scheme deals with the arrangement of electrons in various cells. Various postulates of these schemes are: a cell can contain maximum 2n number of electrons. That means this is the nucleus, and around the nucleus, the electrons are revolving. And these are the cells number 1, and this is cells number 2, and this is the cells number 3. Just like planets are revolving around the sun. So this is the cell number 1 and 2, and these are designated by the naming is K, L, M, and by this formula 2n square we can find how many electrons will be present this type of cell number 1, 2, 3, and n is equal to the cell number 1, and by 2n square, that means 2 into 1 square is equal to, that means K cell has been maximum 2 electron will be present. And next L cell that means n value 2, that means 2 into 2 square, 4 into 2 is equal to 8, that means L cell contain 8 number. Similarly, M cell will be contain 18 number, and the N cell number of electron contain 32, and so on. Next, outermost shell, the valence shell of electron of an element cannot be more than 8 electrons. Next, the numelimate cell, that means the cell just before the outermost shell cannot hold more than 18 electrons. Next, a higher orbit may start filling before the lower orbit is completely filled. Next, arrangement of electron in different orbit of some element according to Bohr scheme is given below. So element hydrogen in the periodic table, the first element is hydrogen, and next helium. This is the K cell which contains the electron 1, and the helium is the maximum K cell contain 2, and the electron will be 2. Next, lithium. Lithium contain the atomic number 3, that means the number of electron will be 3. The first cell will be 2, and the next L cell will contain 1. Similarly, we can see beryllium, boron, neon, sodium. Just we have to see the calcium atomic number 20, and 20 will be contain first L cell will be K cell will be 2, next 8, next 8, next 2, and total will be 20. 8 to 10 plus 18 plus 2 20. Similarly, we can see, and if any doubt, you can comment me. I will explain in the next class briefly. So the first one is how to distinguish what are the atomic number. So atomic number is denoted by universally Z, by taking some Z. The atomic number, that means the total number of proton present in atom in an element is called atomic number. So atomic number is the number of protons. Proton which is lied inside the nucleus. For example, carbon. Carbon atomic number is 6, that means number of proton will be 6. Nitrogen, the atomic number is 7 and number of proton is 7. And oxygen, number of atomic number is 8 and number of proton will be 8. Next, the new number is mass number, which is denoted by A. Mass number, that means the total number of proton plus neutron. That means it is present, actually the mass of the atom is present on the nucleus. So nucleus, proton and neutron is present. So the mass number will be number of proton plus number of neutron. So carbon is, the atomic number is 6. That means the number of proton 6 and number of neutron will be 6 and mass number will be 12. And nitrogen will be number of proton 7 as atomic number is 7 and number of neutron is 7 plus 7 plus 7 is 14. So the mass number of nitrogen is 14. Similarly, sodium will be mass number 23 as the number of neutron and number of proton is not similar, as the number of proton and number of atomic number is same, and but extra 1 neutron is present, which is 12. So 11 plus 12 is 23. These are the symbols which can remember. Sodium, and 11, which is the lower subscript, which is contain atomic number, and 23, which is the upper subscript, script, which is contain mass number. So mass number is the sum of proton plus neutron, and atomic number is number of proton. And when the electron is donated, it is denoted by A plus, and electron is taken by this atom, then it will be negative. That means we have to borrow from someone, so we have to negative. So for example, Mg, when donate 2 electrons, that means it is denoted by Mg2 plus. And when nitrogen is borrowed 3 electron, it is denoted by N3 minus. You have to remember this. Next, you have to task one task, and find the number of proton, electron, and neutrons of the following: oxygen, phosphorus, nitrogen. These are the atoms or molecule and ions. You have to fill up what is the number of proton, electron, and neutron, and comment me on this comment box. What are the oxygen? What are the proton and electron and neutron of the oxygen, phosphorus, and these are the element. And in the next class, we discuss what are the isotopes and isobars, isotones. So thank you.